Okay, so like what I had planned for today was that I can go through the slides that I put up earlier, talk about them in some details, and then I can so I'm currently deploying that extension and the server, but I can like give you guys a sneak peek or like some basic steps, like you have to register a OAuth client and like where to update your like some information regarding that, and then more detailed stuff about like the submission of your tasks. I can talk about for a bit, and then take any questions you have regarding like GSoC proposals, project, and so on. Right. So if okay, so I think I can already get started with that. Let me load the slides. Okay. All right. Do you see it? Okay. Five. All right. So let's talk about like the grid first. So the WLCG is a really diverse environment. So it's diverse in the sense of like there are different types of compute elements, batch systems, worker nodes, middleware packages, which are available. And then it's also diverse in the sense that different site admins tend to prefer different tools these days for configuring and setting up their sites, right? So yeah. No, so basically, compute element like is you can think of it like it's the portal to a site. So, uh, like all these jobs and data and grids are like the scripts which need to be run along with like user certificates which are approved by a virtual organization. So, like the job enters the compute element, which then forwards it to like a batch system, and the batch system works with the scheduler to like push these jobs to a worker node. So at the compute element, basically you can use it for like keeping track of how many jobs were submitted, and then ask it like, okay, ask the batch what's the queue size. So it's kind of like the portal which is open to the world from a site's perspective. Okay. Uh, a site is basically collection of a site is like a data center, a small collection of like just computers where you can set all these services up and then start receiving workloads from the grid. So Martin is here as well. Uh, so
Can you see? Yeah.
yeah.
Hello, hi.
Hi.
So Tarang was basically asking what is a compute element.
Ah, yeah, that's a good question. We have a lot of jargon in our field that we often take for granted. A compute element is essentially an interface towards the grid of a
Yeah,
local, let's say, batch system that the site runs. And so if you have a batch system locally, there's going to be client machines, in the simplest case, personal computers or laptops that can submit jobs into the batch system. They will run locally, and clients can, let's say, query the status of the jobs, right? And at some point, let's say these jobs are done and outputs, let's say, have been returned to the submitting user. So on the grid scale, we have the same concept, except let's say that the client machines are remote. So they are at other institutes, and to get access to the resources of a site, you need some sort of interface machine. It's often called gatekeeper. That will, let's say, do the grid security handshake, and then if all that is well, accept a job submission, for example, that then by that compute element gets essentially submitted to the local batch system. Right, so the compute element really sits in the middle and needs to do the hand holding in both directions.
Yeah. And is there like a compute element, like for all the compute elements to like assign them?
Sorry, can you repeat?
So is there like like something that assigns jobs to each compute element?
Is there something which assigns jobs to each compute element?
I see your point. Yes, good point. In a grid, we will of course have many sites with many compute elements. We need some sort of an information system that keeps track of all these guys. So these guys, let's say, need to be published in an information system. So we have, there's also, let's say, software, or let's say, typically called middleware for that. On top of that, the clients of these grid services, so they are in the end, of course, users, but normally these users are part of what we call virtual organizations. Yeah, so let's say groups of people working on the same project. These virtual organizations, they may also have their own, let's say, private information system of compute elements and also storage elements that they want to use for their activities. Of course, they must have arranged access to those services with the sites that provide these services, right? So that's part of the game. So you either have, let's say, your own private information system. You know, for example, I've got these compute elements at my disposal, and I know also, let's say, the capacity of each compute system. So the number of cores, for example, that are available to a particular VO. At least on average, because a batch system will normally try to honor some sort of a fair share policy to split the time between multiple clients, let's say, that it needs to support. But you can have an idea, let's say, how much capacity you can count on average. Of course, if you start to submit too many jobs to a particular compute element, you will you can conclude that from, let's say, back pressure that you get. For example, you can see that at some point these jobs just stay waiting, right, or queued. So you know, indeed, then if you have too many of those, there is no point in submitting many more, because they will probably also just stay queued. Then maybe, let's say, you've reached more than your share at this moment. So better take your foot off the pedal and give it some time. Try again later when the queue has shrunk. So this is, let's say, how sites, how virtual organizations, or VOs, distribute work over the grid. There can be reasons, let's say, why they want to submit certain jobs to certain sites, because maybe these jobs are going to analyze data that is stored at the site on a storage element, so that these data can be accessed locally instead of over the internet, which is more expensive, more slow, maybe less reliable even. So there can be reasons that say, hey, why certain jobs need to run at certain sites. However, there are also jobs in our experiments that can run at any site. So any free resources, right, can basically be used, um, and there are, let's say, information and monitoring systems to keep track of how the grid, let's say, currently is occupied, and how it is let's say, functioning.
Mm-hmm.
So basically, if you remember, like you were talking about the parameters, which are the configuration parameters last time. So we had like a section for virtual organizations. So like
Mm-hmm.
those VO parameters are what are needed at a site to enable them to accept workloads from the VOs that we specify in our
Yeah.
configuration. Uh,
Okay.
okay, the question answered.
Yeah. Yeah.
Okay.
Um. Yeah. I just also wanted to like ask about like the GSoC proposal, and
Okay.
or did you want to continue with the
No,
presentation?
let me take your questions first, and then I can continue, and then we can like if you have any questions which are straight up on your head, let's like take them first.
Yeah, just like okay, first like I think you need some source code examples, right? So, uh, what could I
Uh,
do like
Tarang,
examples?
we are losing you. Can you repeat that part again?
So yeah, you recommend having some source code examples,
Right.
right? How can I get started on that?
Well, basically, if you have any GitHub repositories or
Mm-hmm.
any projects uh,
Oh,
that you worked on, you maybe like just give us your GitHub handle, or like if you have like some part of your code which may not be on GitHub, but like you feel it's safe to like share publicly, you can just put it in a folder or give us a link that's accessible, and you can take it off after the application period. The idea is just to understand like how well you code. Like, so there are different types of programmers around. Some would like totally go into like, okay, everything is a function, class, blah blah, testing and whatnot. The others are more like, okay, I need to get this job done. So we just like need to have some idea about how you generally go about developing like development and coding in general. So like
okay.
that, yeah.
And is there anything I can do for like related to like the computer elements or torque, or I can write something for that?
You want to write some programs for compute elements and batch systems?
Yeah,
Yeah,
it's like
like
some issue.
I'd say
Okay.
like work on your proposal first, because like don't delay. There's not a lot of time left, so make sure you
Mm,
have a proposal first, right?
okay.
And then whatever time you have, you can start playing around with them. I already
Mm,
have put like the containers on GitHub, so you can try to run them and use them. And maybe like if you wish, you can already like instead of Yame, use Ansible for like just checking out the configuration. Um, like just try to do what Game is doing, but with Ansible. You don't have to do it completely, because that, of course, is a lot of work. But like you just have to
yeah.
like if you wish to, feel free to like understand the flow of how we can like replace Game with Ansible. Like for that level 2 configuration, but don't do everything. Make sense?
Yeah. And also for like the timeline of like what I plan to do.
Yeah.
Um, so how do I, how do I like know what to do? Like, so you have like a week one create Docker images for CentOS 7 containers, and then how do I proceed from there?
No, that's just a example. So in week one, like for your project, you do not have to create Docker images for the CentOS 7 containers. So
Okay.
like what I wanted to show there, I think I'll modify the post, but like I say, it's a sample template. So it's
Okay.
just a template. So basically, we want it has to be up to you. Like like what fits your schedule best. Maybe week one, in over there you are having exams or something. So week one, maybe you want to use week one for like I don't know, maybe like creating UML diagrams or system diagrams, depending on like how you would like to code, right? So like we just know
Okay.
like there are these big tasks, level two and level one of configuration, right? And we have like some code in place that can be looked at, and then what we want is like let's say even if you want to club like week one and two together, so in these 2 weeks I understand game what it's doing in the back, and then week three and four I create like a small pipeline in which I replace like some particular functionality that game uses by Ansible, and
Okay.
then like once you have that in week five, week six, implement it for blah 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 features, and then in the second half, okay, once that is done, then we move on to like level one of the configuration. So like
Okay.
yeah, so like something like that, something which which you envision would be the path forward, because in like Google Summer of Code, we obviously cannot predict the next 13 14 weeks of how development goes. There are obviously going to be bugs and we'll have to make different choices, but it's always good to have like a starting like an initial mindset of like this is the set of tasks I want to achieve. If everything goes well, this is how I will be able to achieve them without being too ambitious, and like just trying to be more realistic. So uh, yeah, that's the idea. And like that what I mentioned there is just a template. Don't like think that you have to create CentOS 7 like images. So
Okay.
those will all those like they are already up, they're using game right now. We just have to replace like inside the image the part of game with Ansible, for instance.
And let's say
Okay.
it should not be let's say rocket science that we're asking people to do. So Yame is essentially a giant shell script that will in turn source all kinds of functions and then run them. And what you see that these functions do is they just put let's say certain bits of information in certain configuration files, and let's say restart some daemons. So that's all there is to it. So game, let's say, was invented more than 10 years ago, um, because at the time things like Puppet and so on did not even exist. And or if they existed, let's say they were in some embryonic state or so, certainly not as popular as they are today. So it was also something, let's say, that was going to be portable. So no worries, let's say, that this is not going to work, let's say, on some system that we needed to care about. It could easily be hacked basically by any admin, right? Because just a bunch of shell scripts in the end. Yeah, okay. It grew, of course, into a fairly complex monster in the end. But the heart of it is still right, a giant loop basically over a bunch of functions that are defined, let's say, per node type, so per service type. So green, for example, has a specific set of functions that have to be run. Each of these functions, let's say, has a required set of input parameters that the site admin has to define. Um, and if one of these guys is absent, let's say it will abort with a fatal error. But, and of course, if some of these parameters are defined, let's say, with well, bad values, then you may end up with a bad configuration. So also there, let's say, we hope that in our project, let's say, we can do a better job to have some sort of amount of, let's say, validity, sanity checking as to the extent possible, right? But to first order, right, we basically say, look, do the same as what Yame is doing, but do it in Ansible, which is a configuration language that is gaining popularity. It will be much cleaner, and people will many people, let's say, in modern IT circles will basically understand this, right? And say, yes, this is useful to also spend time into because I will anyway need similar stuff for other services or projects or what have you. So
Mhm.
so voila. So in that respect, let's say we are not expecting that you change the world with this particular project, right? But we know
Mhm.
it's one of the things indeed that we have on our roadmap that we could use some help with.
Right. So there are already like if you just start the containers which are already available, Martin, do you
Yeah.
know the exact path to the functions?
The path in the container.
Yeah, yeah, yeah.
Yeah, it's all under slash opt, opt, and then you will find the subdirectory glite, right? And then basically a little bit lower, then you have a subdirectory functions.
Okay.
So I think these days, let's say there's very little stuff under slash opt, right, on Linux, because originally, right, in the early days,
Mhm.
all the grid middleware was put under slash opt, right? Because it was all newish, right? And we sort of did not want people to say, is this going to interfere basically with my normal operating system setup, right? So
Mhm.
let's not pollute common places like slash etc or slash bin. No, let's all put it under slash opt.
Right.
Optional, right? So if there's some problem with it, it's optional. So it will not basically screw up, let's say, the root file system that we have. But in the meantime, let's say things have matured, and already since what 5+ years or so, all the middleware is simply put in standard places like used for any other applications. The only exception is Yame, uh, basically because we want to get rid of it. So we're not going to port this, let's say, to a more normal, let's say, layout, right?
Yeah.
Because we want to get rid of it altogether.
Mhm.
Okay. Any other questions, Taran?
Uh, no, I think yeah, I need to just work on the proposal. Yeah.
Okay, sure.
Thanks.
Okay, so I think I can still continue with the presentation and stop me wherever you
Yeah.
think. Uh, So yeah, so I was talking that the grid is really diverse in the sense of both the type of services and middleware that need to be run, and also like the preferences that site admins have to run their sites. So so basically, from a site admin perspective, as you might have guessed, like these services that support like grid workloads are not very common. I mean, Cream Compute Element is something which you'll just use in a grid. You won't use it for any other thing probably at your site. So basically, like setting up a site will require like a lot of insight from a site admin's perspective to be able to run, operate, and maintain everything. So they'll have to look into a lot of new things. So while if we think about like the bigger sites, which are like our tier one and like some big tier twos, so they have the available staff and infrastructure and also the experience because they've been doing it for a couple of years. So they have all these resources to be able to support the grid better. But if we think about like smaller tier two or tier three sites or like people who are just getting started, it's it gets complicated because you have to learn so much of new stuff and you might not be like fully dedicated to maintain your hardware. So
Mhm.
but we should not like overlook the potential of smaller sites. So last year, so last year there was this Boink pentathlon. So Boink is kind of a volunteer computing. It's a Condor-based volunteer computing system which we use at CERN. So it basically allows devices like your computer or workstation to
Mhm.
uh, like provision their idle cycles to run like jobs from the grid. So, like, let's
Mhm.
say if you leave your laptop for a while or you're going to bed and your computer is on, so during that phase, your computer, like the CPU, would actually be running the one like some part of the grid workload. So, which is why it's called volunteer computing, because you just volunteer whenever your resources are free. So last year at the Boeing Pentathlon, so it was basically an event where everyone who was part of like the Boeing ecosystem came online together all at once, and we just wanted to know like what is actually the potential, what's the maximum you can do with volunteer resources, and an impressive figure was like at one point we peaked at like 400K cores from around the world. Imagine the amount of Bitcoin mining you could do with that. But
Mhm.
more than that, like it's actually equal to it's it's pretty close to like the number of cores we have through like these bigger sites like tier 0, tier 1 and tier 2, because
Mhm.
on average we have like 500 to 600K cores uh, through all these like bigger sites. So there's a lot of potential of like smaller sites, and it should not be overlooked just because of the fact that site admins find it difficult to set it up. Does not mean that we should not try to make things easier for them, because like although like looking at one small site we might think it's not useful for the grid, but like if you bunch them together then they have like a really significant number that interests us. So then basically I guess there was this survey was conducted in Czech or
This
uh,
was in 2016. In the fall of 2016,
okay.
we conducted that survey to basically ask. There were a bunch of ideas, right, on how to simplify things at smaller sites. That, of course, also
Mhm.
bigger sites could profit from eventually, but it was not the focus. And so we had been
Right.
discussing this in a few occasions before, and essentially the survey was just, let's say, a summary of potential, let's say, ideas, approaches, technologies, whatever. And
Mhm.
we got a fairly representative set of sites to respond. There were 51 sites, and also, let's say, they were sort of fairly representative across the board. Let's say it was not that we are sort of missing out on some important categories, and we learned a few lessons from that. Right, so we um, we discovered basically which things to pursue and which ideas we better let go for now because there doesn't seem to be enough interest or possibilities there.
Right. Right.
Mhm.
So basically, if you like check out the link, you can go through like there are like some slides in the middle of the presentation where we discuss the questions from the survey. But like the big takeaway from that would be that site admins are actually trying like there's a trend to moving towards like more recent technologies like Docker, Puppet, and OpenStack images for running grid infrastructure. And there's also like a strong trend towards having some repositories which are central enough where all like all these images can be received, updated, and maintained through. So that's where the lightweight sites project kicks in. So the big aim is to be able to like run a site almost by itself with minimal oversight and the operational efforts from site admin, and also to provide the preferred technology for configuration management or for uh, cluster management in a way which the site admins can work with it. And so the dream is that the things essentially remain same from us. That is, they are still running the same compute elements, batch, and middleware, but it's easier from their end to set them up, to maintain them, and to keep them running. Any questions so far, Taran?
Oh no.
Okay.
It's fine. Yeah.
So because this is a new project, so which started like somewhere around almost 5.5 months back, we had like we wanted to set some standards that we can follow and maintain throughout this project initially, so that like the end product that whatever it may be, we know that it abides by these five basic qualities, which will always remain valuable based on these surveys and all the build up behind the project. So the first one of them is abstraction. So abstraction basically means that all these minor level details involved with like compute elements, worker nodes, and batch, basically all these like low level configuration parameters, the site admins should not have to deal with them as much as possible. Uh, so the site admins always find it like, okay, I don't care what cream does in the bottom, I just have this particular container which will run it for me, right? The other is to make the system modular. So modular design is important because people have different preferences, and if they support different VOs, they might need even different compute elements running on their infrastructure. So if we develop this system in a modular way, then we have the option of like just plugging and playing all of these different components rather than doing something extraordinary for everything we want to support or add later. The third is simple deployment. So like leverage the technologies available today, which were not back in the day, like for like containers and for VMs for easy deployment and management. The fourth is to keep things centrally configurable. Uh, so instead of the admin having to like sit on every particular node, set it up, make sure it can talk to everything, we want to have a scenario where you just have like one master node, like a Puppet master or like a Ansible master, where you can control all your infrastructure, run everything from one place, monitor it, and maintain it. And the fifth is extendable. So the way we want to proceed forward is to allow anyone to, because grid is really vast, and we alone cannot like deliver everything which a site requires as containers with the given manpower and time and resources. It'll probably take a lot of time if we do that. So we need to develop this project in a way that anyone with knowledge of let's say for example Arc or Slurm can jump in, use the framework that we have provided, and then implement and use their own containers which run that particular service. So so like to keep to abide by these principles, it was important to have like a document which is a RFC style, like request for comments type of a document, which can give you like a higher level picture of what a lightweight site looks like, what are the different components, how will these components be configured, how will they talk to each other, where are they maintained in repository, structure of repositories, their deployment and releases and maintenance guidelines. So all of this is what we are trying to describe in this specification, higher level specification document, and I'm going to describe it in the next couple of slides. So we zeroed in on like six major components. So one of them is a site level configuration file. So if I so it basically helps us abide by our central configuration principle that I mentioned earlier. So it's one file which sits in the center. You specify all the types of information that can be required to set all these services up, provision your infrastructure properly, and configure it later in one
That's
particular
the
file.
level one, right?
Uh,
Level one configuration.
Come again?
Is that the level one configuration
Yes,
that you
exactly.
talking
Yeah,
about?
this is the level one configuration,
Mm-hmm.
right? And so second is these repositories for all these different components for every different type of compute element, worker node, and stuff. Then we need a configuration validation engine, a central configuration manager, which is like a central Puppet module which works with this central configuration file. We need a networking strategy which needs to be implemented across all these containers. which may be running on like the same machine or different local machines. And then like we need a way to like make sure like CVMFS or like the squid cache for CVMFS is available to our worker nodes. So now
Mhm.
jumping into details of all these components. Do you have a question?
No.
Okay. So the site level configuration file. So it's going to be a YAML based file. So YAML is efficient in expressing information, and Ansible supports it out of the box, and it's also easy to use with Puppet. And it's much smaller than like JSON or XML. So YAML is what we are currently using for this site level configuration file. And the type of information it can contain is basically in five categories. So the first type of information is site infrastructure. So this is where the site admin is supposed to define, okay, I've got these many, let's say, virtual machines, or this much of CPU, this much of storage, and like these are my network restrictions, these many network cards. So these are the types of details that the site admin needs to tell us, so that we have an idea of the infrastructure we are playing with. Like this is the particular part of the data center, or like these are the like cores which we can like run these jobs or like configure the compute element or batch system, etc. The
So
second, yeah.
this YAML file is just a Ansible playbook, right?
No, no, no. It's not an Ansible playbook. This
Okay.
YAML file is not linked to either Ansible or Puppet or Yame or any other configuration management system. It is
Okay.
just a file which will be read by all of these different configuration management systems, which we
Okay.
call like the central configuration module. And then all these
Mhm.
implementations in Ansible or Puppet will find their own interpretations of the file. So if you think from the perspective of a site admin, he does not have to care about what's running in the back. Is it Ansible or Puppet? He just has to like specify the information in the standard format of a site level configuration file. Make sense?
Uh, so so the central configuration will read this
Yeah.
configuration file.
Yeah.
Okay. Yeah.
Okay.
Mm,
Yeah, so
okay. Yeah,
so
makes sense.
we decided, let's say, not to, shall we say, make a hard choice today, because maybe
Mhm.
Puppet is the most popular today, but
Mhm.
in a few years it might be Ansible or yet something else, right? There are other systems still.
Okay.
So we sort of said better, let's say, well, have a meta layer on top of it that would be
Okay.
easy, let's say, to read in basically by any of these popular systems today, right? So we wouldn't need. So if, for example, Ansible is used, then yes, some function, let's say, will have to suck in basically this high level file and then do things the Ansible way, right? But we think that is going to be a piece of cake.
Okay.
So the second type of information, of course, is the components. Like what compute element do you want, Arc or do you want Condor, or do you want Cream? What type of batch system, middleware, worker nodes, and what versions of these particular like site components, and what nodes on the site infrastructure that you just defined. Like what node should a particular component be deployed on, and then like component specific information which we get and define in our repositories. Then
Yeah.
the 3 4 5 are basically more generic information, like what are the users groups that need to be created in the node hosting the compute element and worker nodes. What VOs will the site support, and where are the host certificates which are needed for the compute element. And then miscellaneous information like security emails, support emails, and then background technologies, like do you want to use Docker Swarm or Kubernetes, or do you want to like use a central management through Puppet or Ansible and things like that.
Yeah, so here, let's say, I can also comment a bit. So these users and groups, they are, let's say, well, we call them often grid accounts, right? So the idea is, let's say, that ultimately, let's say, on a machine, let's say, that is running Linux as an operating system, stuff, let's say, is going to run under a particular account. So also grid services and so on, they run on a particular account. It's not always root, right? It can be some dedicated account. Um, and those accounts then will have to be made, right? And there are some further details, let's say, that I won't bother you with, but it's not, let's say, that any particular service will sort of know in advance who is going to use it exactly, right? The only thing, let's say, that you tell the service, these are the VOs, the virtual organizations, that you need to support, right? And then, let's say, there are mechanisms, let's say, for, let's say, users within that kind of virtual organization to be actually able to use the service, right? But that we probably don't, we should not explain in this call. Um, the other thing, the background technologies, right? We, as I said, we would like to be flexible there. Now, it can also be that some of, let's say, the admins that are looking into to using these facilities, they actually are knowledgeable in that business, and they might, for example, say, hey, right, if we use Kubernetes, right, I could add in my this or that, right, or I could extend it because I'm comfortable with that. So we would like indeed the admin in the end to have a choice actually. Of course, it depends on how many backends we have, right? If we only have Puppet and Docker, then that's the only choice that works, right? But in the future, we hope to have a selection of these kind of popular tools, um, and some of that, right, will basically come from others in the community. Uh, and that's also, let's say, why we've defined, let's say, these projects in GSoC to start making make a start basically with this kind of extension in that direction.
All right. Uh, so just snippet from site level configuration file. So so I told you we defined the components, which was like point two over here. So like grid components, right? So the way it would look in YAML is you have like component info. You define a compute element. You tell what repository it needs to be pulled from. So, for example, if it's Cream, then you give the link to the Cream repository over here and specify type, and then you tell which host name, like what is the host name of the machine on which this particular compute element needs to be configured. Uh, and we do it for like the worker nodes and the batch systems and so on.
Okay.
Okay.
Yeah.
Uh, okay. So like I told you about the repositories here, like this particular line. So what
Yeah.
exactly are these repositories? So they are basically um, publicly hosted GitHub projects, right? Which give us like two major information that are required by a site. So first is the code for the image of the component that this repository belongs to, right? So like if you want to start a container, what are the packages it needs? So you define it in a Docker file. The second is like the meta information for the configuration of that particular container. So let's say uh, like you saw all these Cream, for example, as you remember from the last call, it had like several, it had at least like 100 configuration parameters. So like we need to know like this particular component is expecting these 100 parameters. So the site admin needs to make sure that he specifies the values for these 100 parameters so that the container can get configured properly. So these are the two types of information which are mainly available on a repository. And then we have like one repository for every component. So Cream, Torque, Condor in the future, all of them are in separate repositories, right? So it also like makes it easy for us to version these. So let's say Cream releases a new version, which just means we got to create a new tag in GitHub and update our Docker file and any parameters that might have changed.
Mm-hmm.
Right. So, like sneak peek at the structure, it's you can also take a look at it on GitHub. The repository follows the same structure. So, the two main files that we are interested in are metainfo.yaml. They're at the bottom, and the config schema.yaml. So the metainfo.yaml basically tells that okay, this particular GitHub repository is for Cream CE version 2.7, and the configuration parameters can be found under the heading of cream info, and this cream info is defined in the config schema.yaml, where we just tell okay, we need a list of worker nodes, which is a host name array. Right now in the repository, every thing is like string, because I'm like testing the end-to-end flow, but in the future we can define our own rules for validation of such information,
Mm-hmm.
right? And how do we check that the site level configuration file actually contains the proper format for such parameters? So we do that through the configuration validation engine. I think that's also available on GitHub, on the GitHub organization. So the task of the validation engine is simple. Basically, it has to check that the whatever information the site admin specifies in the site level configuration file actually
Mm-hmm.
meets the expectation of all the repositories that he wants to use, and like avoid any silly errors that he might make, or like just validate numbers like they're not specifying I've got 5,000 cores or things like that in a site, right? And the second thing it does is to like check that the available infrastructure uh, at the site. So basically, the infrastructure that the site admin mentions he has actually makes sense for us to be able to deploy all of these repositories. Let's say if he only has like 512 megabytes of RAM and he wants to run like a worker node, so that would not be possible. So like these are the types of information we wish to pre-check uh, before like starting any containers and configuring them. So this part of the pipeline is taken care of by the configuration validation engine. So then comes like this main configuration module, the central module, which right now what I'm writing is in Puppet. So it does several things. So it will use the validation engine to check the configuration file and also like the status of site infrastructure, all the nodes are available or not. It will then like contact the repositories, download them, and then start their containers and then run the configuration scripts from the repositories. It will then set a networking strategy, like for Docker Swarm, for example, overlay networks are available, so they can be like the containers can be connected through overlay networks. For Kubernetes, it's slightly different. So the main component controlling all this implementation of network is the central module as well. So this is the level one configuration I'm talking about, Tarang.
Yeah.
Right, and then it has to ensure that like the CVMFS cache is available to the worker node containers, and then it has
Mm-hmm.
to like submit a test job to check like the end-to-end uh, connectivity of all these different containers, and that like certain types of test jobs like hello world, and then something which uses CVMFS, something uses more data, something which stresses your the cores, like the compute power at your site, like all these like set of tests which can be used to like check the performance of the configuration.
Okay.
Okay. So let's, if we put it all back together and take a look at like the big structure of this entire project, it would be that you've got the site admin who specifies all these different types of information in the site level configuration file. Then in step one, the central module, which can be Puppet or Ansible, which are the two options you are looking at right now. So it reads this YAML file, interprets it, like extracts information like repositories, networks, blah blah blah. In step two, it will then contact the repositories which are mentioned in the files, and then send this information in step three to the configuration validation engine to make sure that the information that the site admin provided in his site level configuration and the information which is expected by these repositories for configuration actually match. So once that is complete, it will check the infrastructure for its validity. That the infrastructure is there. I can like ping all the nodes on which these services are to be configured, or I have access to the Puppet clients, for example, on all of these nodes, and so on. And in the final step, you just start containers and run their configuration script, then submit the test, like do the test jobs to make sure everything works, or like the minimum expected services are up. So the first implementation is what I'm working on. So this central configuration module is a Puppet module. The repositories, which you already saw on GitHub. So the first one is like Cream Compute Element with a Torque batch server, and the worker node has a Torque client configured on it. And right now we are using CERN infrastructure, and as we speak, I'm testing it on AWS. Uh, so that to make it like publicly available for you guys to play around when GSoC starts. And this configuration validation engine is a Python command line utility, which you can check on GitHub if you're interested, but it's not directly related to your work as of now. Maybe like in the during GSoC we might have to like make some commits to it to make sure like the Puppet module, or sorry, the Ansible level one configuration can work with it, but like right, it's not like the starting point for the project.
So this validation engine will just run on the containers, right?
Yeah,
The Docker
it can
containers.
run on the container. It can run on the same machine where we are running like this Puppet Master as
Okay.
well. Yeah.
Yeah, I was just like looking at some Docker unit tests.
Yeah.
So
Okay.
uh, maybe I can link it in the forum.
Sure, that'd be great.
Yeah.
Yeah, so implementation status, like I said, so right now Docker Swarm for container orchestration, and the Docker for like making the images for all the containers, and Puppet for configuration management. And the infrastructure is on OpenStack or AWS, which will become more clear in the coming week, I guess.
Mhm.
Right. Yes, and then you like if you watch the forum, they'll have more updated information on like where these repositories are. When I was making this presentation for the first time, I didn't have the links. So the second implementation is where Google Summer of Code comes in. Uh,
Mhm.
so we'll still be using like Docker for writing our like Docker files for all these components. So the other project, which is the orchestration project, will mostly focus on using Kubernetes for container orchestration. And
Mhm.
yeah, and your project is the configuration project, which deals with using Ansible for at different levels of
Yeah.
configuration. And yeah, so basically, if I talk about like supporting new components, so let's say we put in all this work, and then an expert of Arc or Slurm or Condor chips in. So the way we expect him to, so like I defined earlier in the presentation that this system needs to be modular.
Mhm.
So in the current design, to make sure it's modular, the person should be able to like create a new GitHub project, or in which he defines the meta config.yaml and the config schema.yaml, and then he has a Docker file in which installs all the packages, and like sets all the configuration environment variables and whatever is required for, let's say, Arc, and
Mhm.
then defines like an entry point or a init script which uses the Puppet inside the container, which is basically the level 2, which makes a call to the level 2 configuration to use this configuration site level configuration file to configure itself. So like the modular design fits in the current approach that we are taking. And yeah, so we are already aware. So this is a more technical discussion forum, which is hosted on like the e-groups at CERN.
Mhm.
So here, so like on the Google group, we have more open discussions about, let's say, GSoC, and you can also post questions around Puppet or Kubernetes or Ansible and stuff.
Mhm.
While this forum, we want to restrict it like just for like discussions about the project, like specification, what parameters are like, which are core lightweight side, not related to its implementation, just specification level. So feel free to send a join request if you wish to follow. But there hasn't been any recent activity which we do not already know on the Google forum yet.
Mhm.
And I think we can skip this part. It's not important as of now from the GSOC perspective. But yeah, so any questions that you have?
Uh, yeah, no, I think you did a pretty good job explaining I think what, yeah, this lightweight size project. So will this like new configuration uh, file be used like across like WLCG?
So it is so WLCG. So right now we have like 170 sites,
Mm-hmm.
different scales which are already running for years. So we don't
Okay.
expect like the old sites to suddenly switch to lightweight sites,
Mm-hmm.
because this project is not targeted at like big sites as I talked about earlier. We are more focused on like the people who are new, the people who are small. Let's say a bunch of PhD students who wish to like use data from the grid for their work, but they do not have like because they're physicists, they might not have the expertise of like site administration. So to make
Mm-hmm.
their lives easier, that's or like if any new site wants to come in and work and they want like a easy way to set things up on their site instead of following the usual route of to and fro emails and calls with the people of our team, so they will be able to use like just these packages because these people are more familiar with Docker and containers and Puppet and these type of technologies than they are with the grid. So to the newcomers and less experienced, and maybe like as we mature as a project someday, if a big site has new hardware, let's say a tier one has a new set of hardware, they might be able to just use our containers straight out of the box for running particular services as well.
Yeah, and we have, let's say, so we have, let's say, about 170, shall we say, official sites that
Mm-hmm.
basically have signed a so-called memorandum of understanding, that they
Mm-hmm.
would sort of do their best to be sufficiently available, let's say, for WLCG work and activities throughout the year. So it's not a formal contract, let's say, but it is still, let's say, an official sort of promise, right, that they make. We also have a bunch of sites that do not want to make such a promise. We call those tier 3 sites colloquially. So I estimate that's about 50 or so in various sizes. So you can have quite small sites, right? Maybe a few hundred cores. But there's also some big guys there that simply, let's say, do not want to abide, let's say, by these official policies, right? That you would have to adhere to if you want to have this official status. So in any case, so we have tier 3 sites, but also smaller tier 2 sites that probably would be quite interested in redoing their site in a simpler way. So already, let's say, we certainly have some actual examples, right, where basically we set ourselves, if only, let's say, we already had, let's say, this project in a sufficiently mature state, we would have used it for this site, right? But since we are not there yet, we basically have had needed to help these guys, right, setting things up in, shall we say, classical way. So there will be, I think, almost immediately some takers, right, of stuff, let's say, that we release once we have sort of proven to ourselves that this is deployable. And
Mm-hmm.
And then let's say we suspect indeed that as our let's say fame will grow, that more and more sites will say, hey, wait a second, right? This actually could save us a lot of work. Because in the end, let's say it is not really about let's say yeah, I mean well, there's a lot of investment, shall we say. Mayank said it earlier in this call. That is very specific, let's say, to the grid, right? So knowledge that you need to acquire that you cannot really use for anything else. And we want to reduce basically that amount of knowledge, right? If people need to invest basically time into Docker, Puppet, Ansible, Kubernetes, you name it, that is time well spent, right? Because you can use that for other work that you need to do now or in the future. So, so I think, let's say, yeah, it's something that said that we would have loved to have years ago, but well, yeah, the time wasn't right for it in those days.
Okay. Cool. Thanks, Martin. Any other questions, Sarang?
No, yeah, I think it'll be pretty cool if this works out. Yeah.
Uh,
Thanks for the
sure.
information. Yeah.
Sure. Anytime. So,
Yeah.
are you running late? I think we overextended the call by half an hour.
No, no, it's fine. Yeah.
Okay.